findings. I don't know if I can do that or someone can record.
I think it's okay because it's live streaming. I don't know, Rocio, is it okay for the?
I think yes, the recording is, but it's not. It is Laura. I mean, it's Caminos who can do that for the recording.
But I think it's live streamed, so it should be recorded.
Yeah, it is on YouTube also. Yeah.
Okay.
Well, yeah, perfect.
Thank you. Okay, so
okay, you can start, Jeremy, if you want.
So hello everyone, thank you for being here. I will just introduce myself very briefly. So I'm Jeremy Blair. I'm a professor at École des Ponts Paris Tech, and I'm in charge of this conference cycle for the Master of Digital Twins for this second edition now. And today we have the pleasure to start this conference cycle with the first lecture, which will be provided by Berk Canberk. And Birgul will introduce him just after. So thank you for being here. Welcome to all the new learners of this new edition. So the idea of this conference cycle is to invite people from either academia, from the industry, to speak about digitalization mostly in the construction and transportation built environment field, but also sometimes maybe we'll try to invite people from other fields of application to see how digital twins can be developed and are used in other communities, and to exchange knowledge on this topic. So we'll try to have this kind of format, like 1 hour seminar every like maybe twice a month or something like that. So we will keep you posted on the next sessions. It will be made available on the social media once we have the program is settled. So thank you again for being here, and now I give the floor to Birgul to introduce our speaker, and thank you again, Berk, for being the first speaker of this session. Thank you.
Thank you, Jeremy. Just to add that we will have a question and answer session at the end. Don't leave just after the lecture. We have 15 minutes, more or less, if you have any questions to ask Berk. Thank you, Jeremy.
Okay, thank you, Matthew and Jeremy. Let me introduce myself. My name is Birgül Çolakoğlu. I'm professor for architecture at Istanbul Technical University and also coordinating the digital twin master program at Istanbul Technical University. So I'm honored today to present the first speaker, Dr. Berk Canberk, of the second edition of conference series. Dr. Canberk is the full professor within the School of Computer Engineering at the Napier University, and where he leads interdisciplinary research and initiatives in AI-enabled digital twins of Internet of Things, communications, and smart wireless network. He received his PhD at Istanbul Technical University Computer Science Department and his master degree in telecommunication engineering at Chalmers University of Technology, and bachelor's degrees from electrical engineering from Istanbul Technical University. He has been an adjacent faculty within the Department of Electrical and Computer Engineering at Northeastern University in US since 2017, and affiliated with the Department of Artificial Intelligence and Data Engineering at Istanbul Technical University. He's also the innovation director of BTS Group, the biggest network automation and cloud computing company in Turkey. In last 5 years, he has published over 100 journals, 2 books, 7 book chapters, 3 approved US patents, and 12 patents waiting for approval. Quite a productive 5 years after the COVID. He has been involved with several industrial research activities with leading technology companies all over the world, including research scholarship program funding with Google DeepMind, TÜBİTAK, BTS Group Turkey, Turkcell, Turkish Telecom, and Uniper Energy, Germany. I welcome Dr. Canberk to the second edition conference series from Digital Twins and leave stage to him.
Okay. Thank you very much, Birgül Hocam, Professor Birgül, for this nice introduction. And then I'm really happy to be here with all of you. I am from the early beginning of this nice consortium, and I know the early beginning, so it's been quite good so far, so good. So really happy to be here today. So I will try to introduce you today what we are doing in terms of digital twinning. Before that, I will try to give some brief information about. We already know what is digital twin, but I will try to just give some brief introduction, and then I will talk some kind of use cases and try to wrap up everything if everything goes correctly, like in 30-40 minutes. So this is the outline of my talk that I'm gonna present today. I will mention about my research group a bit, what is digital twin, and our we have like a 3-layered architecture. It's a full stack that we have built from scratch. We have lots of patents and everything. And as Birgül Hocam said, maybe this was the main reason of this production for the last 5 years, because we keep producing about digital twin thanks to this architecture. So we keep doing research. And then I will talk about some kind of use cases, then give you some really brief idea about the platform itself. This is my group. So this is let's say the second generation of my students now. Professor Birgül nicely mentioned about me, so I will skip the left part of the slide. But the most important part for me is to mention about the right-hand side, which is I always call like the real heroes of my lab today. I like this in this period. So like we have several students in any levels, like from bachelor level, from PhD level, from the postdoc level, and then we keep like producing all together. So you know what a digital twin is. Just to make it formal, digital twin is the virtual representation of a physical aspect that we have in the world. You can use anything as a physical object or physical process, and try to mimic its behavior in the digital environment. As the name implies, in digital twinning, you have to have two things. Twin comes from that perspective. In one screen, because this is a digital environment, in one screen you have what you can see, and in the other screen you will have any kind of services that is requested by that specific use case. You see different types of definitions here. Among those definitions, I didn't put, but among those definitions, because this is a bit kind of an AI era for us, so we don't usually Google right now what is digital twin, but we ask ChatGPT what is digital twin, and all this 6 bullets are taken by the references of the ChatGPT. He told me to just IBM has this definition, Gartner has this definition. So if you know how to use it, so it can be kind of even shorten your life if you use it correctly, obviously. So in order to make it for us more concrete, I wanted to put this. I always put and keep the slides. On the leftmost of the slide, you see me. Don't look at me. I'm not important at that picture. But like in the background, you see this lovely Petronas Tower when I was in Kuala Lumpur last year for a really big globe conference for another kind of a key talk there about digital twinning. So this is not a digital twin for us because it's a real twin. So they just have from the beginning like a similar things, and they don't mimic each other afterward. They just build it as it is. They are just twin, but they behave completely differently afterward. So this is not a digital twin that we call in our IT world. In the second picture, I am sure almost all of you have seen Avatar movie. So the idea there is that the guy on the upper side of that middle picture, he's laying down actually. But in another world, in an augmented reality or in a virtual reality, he's a hero and he's doing some stuff. This is not a digital twin. Because in the reality, this guy's laying down, he does something completely different than the virtual world. So in our technical definition of twinning, you have to mimic the real world and you have to do something else. So avatar, you are doing exactly, you are staying there as if you are just putting your glasses and then you are in another world, but actually you are in your room. So this is not a twinning for us. This is some kind of an augmented reality. You are augmented reality. You are just putting something else on the real world, which is another research area. On the rightmost side, this is the two pictures taken from NASA. It's actually a digital twin. Why? Because in the laboratory environment, of course, they don't do exact fuselage, but they are mimicking at the right amount, at the right time, in an online manner, the real behavior of this rocket, while it's really like going up. So it's some kind of a mimicking the reality, and they are trying to forecast what is going to happen in the next 5-10 minutes. So this is the whole idea of digital twinning. This is what I'm trying to say. You have two screens. In one screen, left side, you have real-time monitoring, nothing new. So we already have existing technologies for that, quite improved software area. We have DevOps, we have front-end, back-end, we have different types of dashboards for that already existing. We have like right-hand side, which is independently already existing. Thanks to AI, we are improving them a lot. Thanks to the simulation environments, we improve a lot. But in digital twinning, we are merging these two worlds. So in order to merge them, you need communication. Then we come, as the communication people, we come into the scene, because you have to do it in a real-time manner. Where I was doing also my master degree, bachelor degree, we had been taught as a real-time communication between the real-time world and the next, like the what if or optimization world. So we try to combine these two things. We try to just make a data communication in one side or the other side, giving feedbacks, and then try to coordinate both of them. This is another picture of twinning. One of the questions that I had been really asked a lot was that the difference between simulation and digital twin. Recently, I have not been asked that question that often, because probably the digital twin world is getting in a mature level now. So we know what is it, but it's really important to know the differences. In simulation environment, you can see what may happen in the system. You have the complete freedom to do whatever you want according to your whatever you want model. You are just simulating anything. Whereas in digital twin, you are a bit focused on the reality. Okay, so you have to see what is actually happening in the system. Of course, you have simulation environment, but this simulation environment can be embedded into the digital twin area, into digital twin platform or digital twin software that you have, in order to show you some kind of future aspects. So simulation is just one part of the whole digital twin perspective, a whole digital twin platform. So as you see in this figure, we have a physical space, like anything, and you have like an exact mimic as a virtual space. And then you have what we call the service space, which is, as I sometimes call, where you can get crazy. So you can do whatever you want. There you can be a hero in your avatar world, but in the reality, you have to also be an avatar. So you have to also be that guy. But in the service layer, you can do something else. You can do some optimization. You can do some simulation environment, what if analysis, anything that when you write ChatGPT, the digital twin, these are the benefits of the digital twin, that all these different types of muscles that digital twin can give it to you can be done in the service space. But before that, you have to mimic in real time, in an online manner, whatever you have. So this is the whole idea. Okay, so with that perspective, I do believe that these two things are completely different, 180 degrees different between each other. So simulation is something different. Digital twinning is something different. This is the market size. We try to like always get motivated from the future analysis, from the future space that any research area can go. Digital twin is really promising in that sense. As you can see from this graphic, go up until 2028. You can have even like longer predictions about this. It's up to 2050s. The governments, they are making their plan according to the digital twinning. There are lots of industries are really doing digital twin, and they are quite interested on that, including automotive sector, energy sector, like built environment that I'm working with closely with Birgül Hocam, that they are really working. The digital twin is one of the like hottest topic there. Or smart cities, manufacturing, retail, commercial areas, lots of areas that you can collect the data in real time, or you can collect the data and make it real time is another topic. But with this data, you build your model, or the model is already built and you design your space. And then we are trying to examine, we are trying to understand what is going to happen next, or what may happen in the system in the next 5-10 minutes accordingly. So in this perspective, in this digital twin perspective, we have AI obviously used. We use AI in any layers of digital twin. We can use while collecting data. We can use, we are actually using in order to like eliminate the data or make some kind of feature analysis with the data. We are using AI, any kind of AI. I will not go into detail. It's another like a course topic with 14 weeks to specifically discuss what type of AI models, what type of learning models that can be used in this real-time environment. You can use it for modeling, real-time modeling. Of course, you can use it to do optimization. You can use it for what-if analysis. You can use it for any kind of simulation environment. So AI is everywhere in this digital twin world, because digital twin can just be done if you have enough data. Okay, so since AI and big data, they are like two really, really close friends. In order to mimic the real world and in order to give services as the third layer of digital twin, we will need AI. So there are many opportunities in order to build up a digital twin platform using any kind of AI algorithms that I will not go into details. Okay, so let me, from this slide up to like 6-7 slides, let me really, really briefly just give you like a spot about what we are doing, what are the current or previous but recent research area projects that we are working on with my lab or with several collaborations. One of this topic is like transportation. We are mimicking the roads. If we can get the data from the roads, or if we have an accurate road modeling, for example, in this particular work that you are seeing in this slide is taken from like a transport simulator called Sumo. You are trying to like mimic, for example, in the left down, you see here, as if you can see my pointer. This is the map of Edinburgh. So you can have this map. Obviously, this is not difficult at all from OpenStreetMap. And then you can also have some kind of traffic models. Those traffic models that are static, they can be dynamic, or the best case to put some sensors and get the data in an online manner, which requires some kind of an extra permissions, extra memory of understanding, extra kind of bureaucratic work. But in the research perspective, you imagine that you are just building this part, okay? In the data part, you mimic it as a digital twin and then try to come up with predictive analysis, risk area clustering, CO2 prediction, or like any kind of traffic flow policies, recommendations. It can come up with this kind of services. Here, one of the like research-wise contribution here is that we are keeping all this model in a particular database that we call, I mean, this is not something that we have introduced, of course, this was already existing, a knowledge graph, like with some kind of ontologies, instead of using them in this basic SQL databases, like in a listed databases, we are using particular graphs in order to identify in a better way the relationships and to be quicker, because here everything goes with real time, and real time requires some kind of having the same type of delay. Let me be quite specific here. As communication people, we are okay with delays. We are not okay with the fluctuations of delays. We call it jitter. So we are trying to make it zero as possible, or quite close to zero. So if the delay always the same for us, we are fine. Imagine you are taking the train or you are taking the bus. Why you may prefer the train? Because the train always comes at the same time. I mean, always. And then since the railroad usually these guys goes, they are already defined. So they are using the same amount of time, the same amount of spaces that you can go from A to B. So the delay is always the same, the time amount that you are consuming, but their jitter, the fluctuation of the delay cannot, I mean, they're quite low. So it's quite preferable. The same thing happens with the real-time communication perspective of digital twin. You may have some delays, but if you have the same amount of delay, you can mimic it completely in the digital twin world. If you are receiving this data in a random manner, then this makes problems for us. You have to somehow adjust it accordingly. So this is a bit technical, I know, but just to give you a glimpse about the real-time communication perspective of the digital twin, which is the core, one of the core research areas of this whole digital twin understanding. Apart from this modeling, apart from the 3D perspective, apart from the data gathering, data pipelining, this real-time communication, part of digital twin is really important for us, is really make, I think, a difference in our group, in our research groups, so that we are trying to mimic exactly the real time as it is. This is another example. As I said, I will just give the idea and I will pass. These are all the really huge project with several different members all over Europe, like, as you know, the consortiums and everything. This is some kind of connected vehicular systems in order to understand the behaviors of the vehicles. This is quite, let me say, romantic to me, because this work has started 5-6 years ago, when I just become, like, I got promoted to ITU at that time. And when we did this work, Birgül Hocam probably, she already recognized that stadium, so which is our stadium in Maslak. When I was like full-time there, we did this drone-based stations. We didn't know that we were doing digital twins. I had no idea as the group leader, as the project principal investigator. We were just trying to simulate in real time the drone, like we were just based drones that are flying. We were putting some base stations and try to adjust their behaviors, like their altitude, the height, or attitude, or the data communication among them, in order to maximize their coverage area. And we were doing this. Laptop is the digital twin second screen, actually, that we didn't know at that time. We were trying to like send information, receive information, to like adjust this swarm, like this drone swarm, to make this coverage area as effective as possible. It turns out that this is really a digital twin that we were doing at that time. So we had, after finishing that project with TÜBİTAK, which was a really early work. So I'm really proud of as my home country, Turkey, because we did this digital twin like 5 years ago. And then now in UK here, we have a new version of this now as a digital twin, like, because it's actually a twin for us. Then we are trying to make this real-time communication perspective. We are working on some kind of aeronautical researchers. We work some kind of drone people in order to make this coverage area with the GSM company, one of the biggest GSM company in Turkey, actually, to make some kind of proof of concepts, to make this digital twin of drone-based stations happening in real life. Another one, like to understand what type of drones, what type of locations you can use, you can select when you have some kind of disaster in an area, because as we all know, the communication system can go down. If we are building a digital twin there, what are the possible locations that you may use to locate the future locations, future ad hoc and temporary locations of those base stations in order to make the communication alive. This is an interesting one as well. In this one, we are trying to, again, cluster the high altitude platforms are like planes up. We are trying to cluster the cruise level planes and then try to give like a recommendation for the next 5-10 minutes while you keep receiving the data in real time. We are trying to give recommendation for 5-10 minutes about each and every aircraft to use what kind of antenna in order to provide a 30-35% better internet connectivity within the aircraft. For this challenge, I had no idea about that challenge because I'm not an aerodynamic person, obviously. I don't know, I don't work in that area, but this was a use case which is really interesting for us. What we did here is to build up this real-time modeling, real-time, which is important. As you see here, I will show you if I have time, the platform, we have a particular use case for that. So here you see there's a video if it works. So at the time of we record that video, so you see the map of UK and those airplanes are really real time. We are taking an online and a free network, open sky network. And then we have two screens. In one screen, you see the exact mimicking of these guys in a 3D platform. And here you see the next 5-minute clustering. Why we do that? To show that in the next 5 minutes, this guy can use either their satellite antenna or use their ground antenna or use their ad hoc antenna to connect to the other aircraft to have a better connectivity. So here you see the recommendation engine that we are giving according to each and every cluster. It's another use case for us that we are using in our platform. This is the Royal Society project that we are trying to mimic the air quality of we started with this lovely city York. Then in the second project we are doing now with Istanbul and Edinburgh. Of course, there are two big cities. Istanbul is a huge city, as we all know. Edinburgh is relatively bigger than York. So we are trying to again find out the correct models of the roads and the emission models. We are not testing them, unfortunately, in an online manner. I wish we could, but just putting sensors and getting the data. But in that particular research area, we try to have a distributed data modeling in order to have air quality, real-time air quality monitoring. Like crowdsourcing is a specific technique that this is a known technique. Probably some of you already know, to find out, to cluster the data, to gather data, and to give some information about the data. This is another interesting use case that we are doing. We finished. So this is some kind of novel communication perspective. What we are using, what we do here, basically, we are trying to tell to the commander of each and every ship to approach in a way that it will cost this ship as fuel as less damage as possible. Again, I had no idea about that use case because it's not my area either. We are still working quite heavily with naval faculty of Istanbul Technical University. There we have some really experts, including Ömer Kemal Kınacı Hocam. Maybe Birgül Hocam also know about him. He's now the dean of that faculty. So try to understand the data, and of course to recommend some kind of new way to collect data. Like if we put some drones to collect data there, what's going to happen? This is not reality. We are just using simulation environment to put drones and then to gather data to come up with some kind of cybersecurity attack detection, because it's interesting to me as well. But we are told that in that data collection, in naval communication perspective, there are lots of attacks, so that they can reroute the ship in order for him to hit, or in order to grab the data so that they can do whatever they want. So it's quite a vulnerable area for them. It's been, I had no idea, as I said, as I'm telling you, but this is an area that we can implement our real-time digital twin platform, and then to come up with some kind of impact, some kind of an impactful research. So as you see here, I keep telling all this research one after other, just to show that digital twin in such an area that you don't only do research, but you also give some impactful outcome. Impactful outcome meaning can be directly implemented into the industry if all the conditions are met. It's not something that is flying outside and you don't do it, you do it just to do it, but you are trying to also have some kind of a benefits to the industry. Another autonomous network, another anomaly detection, let's say, try to understand the data anomalies in a communication by taking into consideration all these different types of ISP, call them ISP core network, meaning that in order to make the communication happen in a country or in an environment, you have to use these internet service providers, and that they have some particular network devices to make the data connected all over that environment. So this is again vulnerable. Of course, they have lots of algorithms here, but we are trying to like monitor them by just taking some real-time data, not real-time, but real data from the biggest ISP of Turkey at that time, and we keep doing this here as well in Edinburgh, and then to mimic we call it autonomous networks, and try to understand the anomalies in that communication. And then, for example, say that one of these, we call them routers, one of these network devices is too vulnerable for attacks, shut them down, or some ports of that particular particular device here can have 95% of the time some kind of attacks according to our digital twin recommendation engine. So do something, or vice versa. This according to the data that we are receiving, our digital twin recommends that this is quite a green area. Nothing will happen in the next 5-10 minutes. So you have to, you can just leave these guys' work as it is. You don't have to run some like extra security algorithms and then spend energy, spend time, spend people there, and then focus somewhere else. So give this kind of online and dynamic recommendations. A similar one, I will just be quick. For the anomaly detection regarding the vehicles, to route them in an appropriate manner among the vehicles. I am not talking about within the vehicle. I am talking about the communication among the vehicles in order to have a better understanding of the flow of the vehicles, and then the traffic lights and all the different types of traffic management of the road. So in the last part of my presentation, I will really briefly talk about the platform that we have. So these are my students that we are working on. So we got recently some kind of an award from IEEE Communication Society because of our this platform and this real-time capabilities of that platform. And then as a platform, as you see, we have just screens. I mean, this is a platform, but what is happening here actually behind that, there are some kind of codings and all these things, all these graph databases and AI algorithms, real-time AI algorithms going on. But you have here just a screen to show you this platform can be. It's quite trivial, as you see. It's quite proof of concept, but this is the idea, right? So we are not here to make a product. BTS Group, which is the biggest company in terms of network automation and cloud in Turkey, they are still providing us their real-time servers in a quite effective manner. So thanks to them, we can build this environment, and then we keep receiving the data, we keep receiving this simulation what if analysis, optimization, as we want. This is the system architecture. I wish I could give all the details, but because of the time constraint, actually, not because this is so secret, but because they are all patented, actually. We got the patents of all of these layers. So we have like 3 layers. You can have even 5 if you include the communication among them. Try to build this platform. This is not something that new. If you know how to build up X as a service, like in the cloud form, like in the cloud environment, you have different types of as a service thing, like software as a service, platform as a service, anything as a security as a service. Those things are coming with layered architectures and try to be attacked in a separate manner. So we are using a similar software engineering approach. This is the communication part of it. We are using a particular communication protocol. We are designing from scratch because all of the existing one, they are not quite feasible to be used in that digital twin platform because of the amount of data that you are receiving, because of the dynamic behavior of the recommendation engine that you are building. You have to design a new communication protocol. So there, the CS people, us, and the communication people should get merged to come up a complete new paradigm. This is the data part, how you gather the data, how you collect the data, and process the data, how to use it, like in the knowledge graph, another topic, instead of using like just a basic way to store them in a table and then to join them using, if you know a bit SQL, you know about this specific command, like I was using in my bachelor time, join, in order to join those tables, but it requires some time. We are using a particular ontologies and particular graph to make it as fast as possible. This is the idea why we are using graph apart from the SQL that we were using. And these are some kind of screenshots that I put here. I have some videos. I can just, while describing the platform for you. This is actually this is quite of course it's a video, so this is not real time right now at like 12:41 for Edinburgh time. But at the time of that video recording, we really have those kind of sensors in that room. And on the first screen here, you see the real time. Let me pause it. This is the real time digital twin at that time, at 10 a.m. And according to that first screen, you remember I was mentioning about 2 screens. And this is the first screen that you see the reality. Okay, so according to that reality, this part of the room that we are actually gathering using our CO2 sensors, this is the map of like big room with lots of small tables and workspaces. This part of the room, according to the heat map, it looks okay. So it looks green. This part, it looks red. So at that moment, there are people or there are something that's going on. So it's red. So this is the real-time heat map, real-time CO2 heat map of the room. Whereas the second screen tells us 3 hours from that moment, a prediction, obviously, but with the 99.999, you know, this 59 rules of, we are taking it from the 6G perspective. This is not 6G at all, but try to get some kind of parameters from them and using a particular LSTM algorithm and an AI algorithm to use, like long, short term. You don't need to know the details. To estimate the future behavior of the CO2, saying that, okay, here, for example, it was green, that part, but 3 hours from now, this part will be, according to the data that we are receiving, this part will be a bit red, so do something. Here, in that particular work, since we actually have those sensors, we transform them, transform meaning we keep as it is, but in a software manner, they become an actuator to open the door, to open the window, to do something when it becomes 1. When the time gets to 1 p.m., they do those things. Or, you know, in several meeting rooms, like this kind of big room, there is like occupied or in use or available, this kind of alert mechanism to enter the room. We call it like admission control. So this automatic system can also change this admission rule accordingly. The same that I was mentioning previously. Good. I'm almost finishing. They like try to mimic the real world aircraft movements and then come up with a clustering idea. This is with the wind turbines to understand the future power production, future energy production of two example wind turbines, not even wind farms to come true. The green one is the first screen, let's say. The yellow one is the second screen. So the yellow one is some kind of a prediction of the reality. As you see, it depends on the data that you are gathering. You can get really falsy estimation as well, which is something okay for us because this is some kind of a research, how to make it overlapped. This is the idea, but it requires some kind of an extra online data management that we are working on. This is with the transportation. So you see some kind of a congestion part, and this is the physical twin. This is the estimation twin. And you are trying to estimate the future behavior according to the already existing traffic lights or the traffic flow, and then to come up with a recommendation. Being said that, okay, I wish I was on time, and I wish I didn't bother you too much with too many research details. I did my best to wrap up things. If you have questions either now or later on, I will be more than happy to discuss. That's me.
Thank you very much, Berk. Thank you. So we have some times for questions, so don't hesitate to unmute yourself or write some questions in the chat. So if anyone has a question. Yes. Oh, sorry. So maybe I can start with some questions while.
Yep. Yes.
So I was wondering in the CO2 use case that you mentioned, how many sensors are there in the room?
40. It was 40. I don't remember the exact number, but when we started, it was 40. It was quite a small room, so we were just putting. We were advised to put using like a guy there, so to know the best places to collect data. So it was like 35, 40. I mean, in that level, not like hundreds and hundreds and 200s.
Okay, because you mentioned also a CO2 diffusion model in MATLAB, or I don't remember exactly. So is it something where you have the point, the punctual value of each sensor, and then you extrapolate over the whole room to have the heat map?
Yes, exactly. We extrapolate and we use this model that we don't. We are given. We don't know the formula, and we are not expert on that area, as you can imagine. But that we are using data to put in a right format, to use that formula to extrapolate, to have this map, and to have some kind of accuracy issues, obviously, which is the idea. I mean, you cannot have it perfectly, but with some kind of a 95, 96, or 99 of accuracy. We are told that this is nice, so this is okay to use. So we use those expertise, not us, to model the data part of it. So this is not our part, actually. This is just, we are just modeling it, and we say, is this okay? Is it looks good? And exactly similar work that we are doing with Virgüloca. Like this is the BIM, like the building of the model of the building. Is it okay? Is it this one? Or do we do something like absurd or what? So an expert should tell us all the different details, for example, with the formula, with all those things, and then we are saying, okay, now this is our turn to make it online available.
Okay, thank you.
Yeah.
So we have questions in the chat. I don't know if you.
There is one other, Fatih Çolakoğlu. Other than maintenance prediction and placement optimization, where else could the digital twin could be useful for wind turbines? Yes, a very nice one. Actually, apart from the maintenance, apart from the placement, you can use it to understand the behavior of the maintenance, like the health performance of the entire farm, not only the single wind turbine, but the entire performance of the farm. Moreover, you can take ideas about the meteorological perspective. By the way, this is not my area, as you know. This is another, like, this is the wind turbine area. But according to my recent use case specific expertise, which I am not a researcher at that perspective, the hottest topic to be given to the digital twin is that how the meteorological, how the atmospherical perspective can change, how the atmospherical parameter can change according to that digital twin. How many wind turbine can be placed and where in a farm, not in the topology, but in the farm itself. What are the angles? As I said, it's a huge and really lovely area. What are the angles? What are the possible angles to put at each and every wind turbine in order to operate in a better way, in a more effective way? How to connect to the grid system, because this wind farm, like you collect you have the wind energy, you convert into energy, electrical energy, and you distribute to the city using the grid. Okay, this can be a smart or this can be not smart. If it's a smart one, you can have a reverse engineering to get it back. Okay, this kind of research area that can be studied. I actually did the latest one. This is because of my electrical engineers day that I got my bachelor degree, because in my bachelor degree honors project back then, 25 years ago, we were doing this kind of grids. It was not smart at the time. We were not doing it smartly. We were just using some rules based. But this digital twin in the wind farm can be used to estimate the behaviors of the smart grid as well. These are some things, Fatih, that comes into my mind. Of course, we will actually discuss later on.
If I may, I just add that we had a project last edition of the master on a digital twin for wind turbine.
Okay, very nice. Very nice.
So, and we can find some materials on the website of the master and the defense of the project also.
Okay.
Just a small part of it. I have just a quick question, Berk,
yes,
regarding the platform you developed. So I know, like as you said, software as a service or platform as a service. I haven't seen yet digital twin as a service, but the aim of this platform is only to be used internally in your team with your use cases, or do you plan maybe to
in the most critical part, your voice has gone.
let everyone connect to it and plug in their own data and use them? What is your, is it to be used only? Sorry, my connection is, yes.
You were cut. So
can you hear me now?
Matthew, I heard you and I can extrapolate the question. I think I got the question, because this is one of the questions I got. I mean, you were asking if this platform will be only like internally available, or do we have any idea? Actually, we are in the process of making it available, since it's with a company called BTS. So it's a bit like a company wise, not completely open, because we did it thanks to their real-time servers, let's say. But we will have shortly like a version in order to be played with. We will open the sources, the codes to GitHub in order to make it to be played with, in order to have some commands about that, in order to have some commitment about that, and then make it available. And I am always really happy and then quite welcoming if we can discuss some new use cases.
Because I was wondering, like, because you must have taken some decision about the standards of the for the data, like what kind of format you use. I mean, interoperability of this is a huge question always. The interoperability of systems.
Not only interoperability with you, like it's a perfectly logical question, and also the privacy concerns of the data.
Yeah, exactly. Yeah.
I mean, as a person who works in digital twin research, I also don't want to give my own health data, for example. Why to give it? Or the CO2 level of my room, why to give it to you or to Virgil Hocam to understand that when I was in that room or what's going to happen. It's a privacy issue, as you got the idea. It's also interoperability. I can give you the text data, but not my picture, not my video. So different types of data should be gathered together. We have what we call in software like adapters and orchestrators to make it happen. These are all the built, and one of my PhD, she is particularly working on that software perspective, how you can gather the data, how you can make it available, that to be used in that platform. So there are cases that are like already documented. Yeah.
So you will provide an API.
Yes. It is
already API with
it is already in, as you can see, you could imagine, but it is not publicly available, obviously. So
thank you.
But we will do that. We will do that for sure. Yeah, in a short time. Yeah.
Okay, we will stay tuned.
Yes. Please, we can discuss offline later on in order to. I mean, you don't have to wait for this. We can just have like another kind of a talk to work together to get used to that platform. It doesn't have to be so far away. I mean.
Yeah, thank you. Anyone has a new question?
Yes.
I think there's someone. Let me see.
Yeah, in the chat, there is one in the chat. What is the appetite from a government point of view of replacing some of the existing operational systems? For example, rail, motorway sector with gel twin solutions.
Yes, another similar and quite a logic question, like the one of Matthew we were discussing. Like there are like privacy issues, there are like interoperability issues, but as far as we see is the community, the digital twin is one of the area that the governments, they are really keen to switch on, to understand not only the future behavior, but also the already existing maintenance factors, already existing behavior. So this is wherever we have like this IoT constellations, IoT deployment, it's supposed to become like Internet of Things. So this is the idea in terms of digital twin world to become. So I think it's a good way for all the governments to go to that point. Of course, there are lots of bullets to be addressed, obviously, not on the technological part, but to make it correct in a correct manner. But this is one way to go to see the real-time monitoring and to also have some kind of future what if analysis, future maintenance, future predictions and forecasting.
Yeah, what I see sometimes is difficult to convince some of them to spend some monies on these kind of things.
Yes,
because they don't see the ROI right now, the return of investments. So they always ask you, okay, why do I have to pay? What will I earn with that? And what is the
catch? What is the catch?
What's the catch? Yeah, exactly. Yeah.
Yeah,
so sometimes it's complicated.
This is why we got rejected several times with the projects. I mean, why should as a paper, as a patent, very well done, but why should we pay? This is the idea. So that's why it should be impactful, as much as impactful as we can. For this, we need data. For the data, you have to convince. So this is some kind of a loop that you have to get out. But
and to launch the wheel, it's complicated.
Exactly.
Yeah.
Yes.
And sometimes, I mean, people like from a government point of view, they don't have the people. I mean, internal people like with the skills to manage this kind of tools.
Yes, exactly.
So they don't really understand exactly what they see that as a black box.
Yes.
And they just as like a software, but it's not just a software actually. It's more than that.
It's a huge platform.
It's a huge platform and a collaborative platform, and they have to So it's a lot of it impacts a lot actually.
It's an interdisciplinary platform, as you say, Matthew. It's not only not like a small MATLAB code or a sophisticated PhD thesis to sell something. So it's I have to use your or Birgül Hocam's knowledge for that. So other than this, I can just make it up. For the paper, it's okay. It was okay 3 years ago. I could make it up. I could use a simulator. For example, in Sumo, in this transport simulator, we could use them to make this happen. But when we write it as a proposal, project proposal, they were telling us, okay, this is not realistic, and we are doomed. I mean, that's right. We have to use their own data for this unit IoT. So this is an interdisciplinary.
Interdisciplinary. Sometimes it's complicated because people work in silos and they don't communicate a lot between different services.
Yes.
And so I've seen that with cities, and we want to create smart cities, digital twins.
Yeah,
but
there
sometimes,
are lots of, but we are progressing a lot. You know, last week I was in Spain in Malaga in University of Malaga, and we had like a huge and like relatively condensed workshop about the digital twinning. And they also, I mean, in the university level, not only them and not only us, there are several universities in local level. We have platforms. And in the EU level, there are like city-wise simulators already like being developed. In Luxembourg, for example, they are really this is fantastic. So there are lots of things that are going on, but yeah, it's something to be improved more, obviously.
yeah.
But what I think is that probably we need also economic feasibility models to be added to this research, so that city planners or city governors or administrative bodies can be convinced into that, because they always say, okay, it's good research, thank you. But as you said, that why should I pay for this? If we can really convince them in long run, like with feasibility reports of the saving money, optimizing, whatever, then they will invest the money.
Yeah, right. Sometimes it's difficult to foresee this kind of impact, but yes, that's the idea.
Yeah, but I mean, we need another group of the researchers to be included to this research to really elaborate from the economic, financial perspective. Let's say, do digital twins of economic models.
Yes, yeah, exactly. This is another, Birgül Hocam, another topic that we have to really do this. Really, it's digital twin of economical models, in order to understand the future behaviors of them, then to fit to the real to the other topics.
Exactly. I know that MIT is doing that. They are doing this economic feasible models with AI to really make it this like a tangible and applicable for the investors.
Okay.
The investors.
Okay. Yes. I didn't know about that. There are lots of things that are going on. I mean, I couldn't catch up everything. Thank you.
It's very hard to catch up.
Yes. Yeah.
Yeah, it will be for another lecture. Like the economic part can be interesting.
Yes, exactly.
We have a new question in the chat. I think it would be maybe the last ones.
Yes.
Whoa.
There are two.
There are two questions. Yes.
Yes.
So again, on the wind turbine.
Particularly for maintenance and extending lifespan and predicting failures and material fatigue, I want to make a model using. Yes, without finishing your question, Jambora, I am not a wind turbine expert, as you could understand. I mean, how applicable is the structural monitoring? I would say, since this is when it's come to us as a data, it's totally applicable, but it depends on the wind turbine researchers to come up with a correct answer about this, because it's a use case for us. If it was with the building environment, I would pass the ball to Birgül Hocam to answer that question, but it's a wind turbine. I don't know if it's, for me, I mean, you can understand the structural behavior of the wind turbines.
It can help you. It can also help you to optimize your model, your physical model. I mean, with real data, you can adapt your model when you do simulations. Using the data to be sure that your model is accurate.
Yes, the
simulation.
What was the most challenging digital twin you worked on? What difficulties? Yeah, it's a good question. It's another good question, like the others. The most challenging, all of this is challenging, I would say, but the really most challenging one was this aircraft one, because of the fact that it's a too dynamic environment. The aircraft are obviously they are quite fast, and try to cluster them in the future, try to like forecast their future clustering mechanism, because they can also go down, change direction so quickly. So this dynamic behavior of the data also required us to use a particular algorithm to change the graph database, because you have to change the graph database in order to forecast more effectively. So we were having delays while changing the graph, because if you work on graph databases, actually by default they are not suitable at all for real-time communication, which is something quite interesting. We are using them in real time, but in theory, naturally, when you do that, they stay as it is. You have to, when you change the graph, it takes time in second manner, which is quite long for us. So you have to use some kind of speedy ways to change some part of it, do another run, change some part of it, do another run, and do it in a quite few line of codes. So this was quite challenging for us. That's why one of my PhD students, she got her PhD recently with this work. So with lots of papers and project, like 2 projects, but lots of papers to come up with contributions. So this was one of the most challenging use case that we were using. I don't know if I answered your question. But...
Okay, thank you. I think we will stop now for the question. Thank you again, Berk, for being here today. It was lovely to hear your talk. Thank you all for having attended to this session. It will be available on the YouTube channel for people who are not available today. We will keep you posted for the next sessions of the conference, and we'll be glad to see you for the next times. Thank you again very much.
Yeah, thank you, Berk. Thank you, Birgul, and yeah, pleasure to meet you once.
Okay. Yes. So
One day.
thank you.